If you're a history buff or a survival enthusiast, I'd say go ahead and hit subscribe now, because today we're diving into a story that really turns conventional wartime engineering on its head. Most people, they think of sandbags, steel and reinforced concrete as the life-saving materials during the Second World War. But there was one unexpected material that quietly saved thousands of lives. And, well, it wasn't what you'd expect. By the end of this guide, you'll not only understand its historical significance, but also how this bit of knowledge can be applied in modern survival scenarios. The overlooked material that became a silent hero during the Second World War. During that time, the demand for traditional construction materials absolutely skyrocketed. Steel, concrete and timber were all being prioritized for weaponry, ships and tanks, you see. Civilian shelters and emergency hospital wards were often left with shortages. It was in this context that an unusual material, compressed fiberboard derived from cellulose, hemp, and, surprisingly enough, even mushroom mycelium, became a real lifesaver. Engineers found that under high compression and with the right sort of treatment, these materials could absorb blasts, insulate against temperature extremes, and even resist shrapnel penetration. In occupied Europe, especially in the UK and parts of Germany, local communities were actually encouraged to retrofit basements and public shelters using these fibre-based panels. They were light, cost-effective and, importantly, they could be produced in massive quantities using agricultural byproducts. What's truly remarkable is that these materials performed just about as well as the heavier, conventional reinforcements when it came to protecting civilians from nearby explosions. So, how did engineers turn such a humble material into life-saving technology? Well, the process was, honestly, more sophisticated than you might think. Compressed fibre panels were layered with waxes, resins or oil-based treatments which made them water-resistant and fire-retardant. In bomb shelters, several layers could dissipate the energy of an impact, acting much like the modern composite armour we see today. Hospitals even converted operating rooms into protected zones by lining the walls with these panels, which prevented devastating collapse when conventional walls failed. This wasn't just theoretical. There are documented cases from Berlin and London where shelters reinforced with these panels survived bombings that, levelled neighbouring structures. Engineers would often interleave panels with sand, gravel, or even old textiles, creating a sort of hybrid system that combined energy absorption with structural support. For those of you looking to apply this historically informed insight today, the principle is the same. Layering lightweight, treated fibres with more rigid materials can dramatically improve a structure's resilience without excessive weight or cost. Why this material was uniquely suited for civilian survival. Traditional shelters relied heavily on concrete and brick, which are strong but, brittle. When a high-velocity impact occurs, brittle materials shatter, causing deadly debris. Compressed fibre, on the other hand, flexed and absorbed energy. It redistributed shock waves across its surface, preventing the catastrophic failure of walls and ceilings. This flexibility made it ideal for civilian use, especially in urban areas where space and rapid deployment were critical. In practical terms, modern survivalists can learn from this. Using natural fibres combined with resins or waxes, one can construct temporary barriers, insulated shelters, or even makeshift protective panels. Whether in prepping scenarios, outdoor survival, or even emergency home reinforcement, the underlying principle, lightweight material plus energy-dispersing design, remains extremely relevant. The surprising secondary benefits, really extended its usefulness. Beyond just structural protection, these panels provided thermal insulation, which reduced the risk of hypothermia in those winter shelters. They were also breathable enough to reduce moisture buildup, lowering the risk of mold and illness in crowded conditions. In hospitals, this meant that medical wards could remain functional even during heavy bombardments, and in civilian bunkers, families could survive for weeks with far fewer complications than you'd see in traditional concrete shelters. This teaches us an important survival lesson. Materials that are multifunctional often outperform single-purpose solutions. In modern prepper or survivalist contexts, thinking about secondary properties like thermal regulation, moisture control, or chemical resistance can really make the difference between a temporary refuge and a sustainable one. One could, for example, use layered natural fibers and resin to create a compact emergency sleeping area that doubles as a blast buffer in extreme situations. Now, let's talk about how you can actually translate this World War II innovation into, modern survival planning. Step 1 is really about understanding material behavior. Lightweight natural fibers, hemp mats, or even treated mycelium can all be layered with sandbags or plywood to create these energy-dispersing walls. Step 2 is treatment. So waterproofing and fireproofing your modern analogues can actually replicate the protective qualities that made those World War II panels so effective. And then, step 3 is modularity. These panels can be transported easily and installed quickly, making them just ideal for temporary urban or wilderness shelters. Beyond emergency shelters, this concept stretches further. It can be used for gear storage, insulated rooms, or even do-it-yourself protective barriers for disaster preparedness. The historical examples give us a kind of blueprint. Flexibility, layering, and multifunctionality were key back then, and honestly, they remain key today. World War II's compressed fibre panels remind us really that innovation often comes from necessity and resourcefulness, not just brute strength. Studying these materials lets modern survivalists and historians alike appreciate how small, sometimes overlooked technologies can have a profound impact. By applying these principles today, we can enhance safety, conserve resources, and design more resilient emergency solutions. If you found this deep dive valuable, do make sure to subscribe to the channel and, share it with fellow history enthusiasts and survivalists. Understanding the ingenuity of the past isn't just about appreciation. It's about practical knowledge we can carry forward into our own lives.